In this question, we have the function x cubed plus x squared y plus 2y squared, x and y are positive, and x plus y is less than equals to 1. So you're basically looking at this triangular region. We want to know what is the minimum value of the function over this triangular region. Let us begin. First, we need to find the critical values by taking the partial derivative of the function. Partial derivative of f with respect to x is 3x squared plus 2xy, and assume y is constant. So that's why the derivative of 2y squared disappears. You can factor out x, you get 3x plus 2y times x, and you're going to set it equal to 0. By setting this equal to 0, you get x equal to 0, or you have y equals to negative 3/2 x. Let us take the partial derivative with respect to y. In this case, x acts like a constant. So the derivative of x cubed is 0. You end up with x squared plus 4y. And you set it equal to 0. Please note that your x from the first equation is 0, and we consider this as a system of equations. We need to solve this together. So when you plug in x equal to 0, or y becomes 0, or y is 0. What's the meaning of that? It means that 0 and 0 is a critical point. Now, if you plug in y equals to negative 3/2 x into the second equation, it becomes x squared plus 4 times negative 3/2 x, which is x squared minus 6x, which can be written as x times x minus 6. You set it equal to 0. But this equation has solution 0, which gives us the exact same critical point, 0 and 0. The second solution is x equal to 6, and it gives us 6 and negative 9. So far we found 2 critical points, and then we move on to the boundary points. The critical points 0 and 0, 6 and negative 9, they are interior, and they are inside the domain. Now for the boundary points. On the line segment 0 to A, or if you call it OA as a line segment, as you can see, your y is equal to 0. Your x is bounded between 0 and 1. You can reduce the function. Remember that this is our goal, to reduce the function to a one variable function. So this function, when y is equal to 0, becomes just x cubed. So wherever you see y, you're going to just plug in 0. So these two terms, they just disappear. But x cubed as a function has a minimum value at 0, which is going to be 0, and has a maximum value at 1 and 0, which is just 1. We are looking at the endpoints 0 and 1. On the second line segment, OB, from 0, the origin, to B, as you can see, your x is equal to 0. So x is equal to 0, y is bounded between 0 and 1, as you can see. And if you reduce the function by setting every x equal to 0, now we are going back to the original function, everyone. It's all about the original function. F of x and y becomes 2y squared. And you have a parabola now. For this parabola, the minimum value is 0, and the maximum value is equal to 2. Okay, let's take a look at another line segment, which is AB. So this line segment, that connecting A to B. On this line segment, as you see, since x plus y is equal to 1, y is 1 minus x. So wherever you see y, you can substitute that with 1 minus x. And x is bounded between 0 and 1. So your original function can be written as x cubed plus x squared times y, which is now 1 minus x plus 1 minus x to the second power. And it should have a 2 next to it. Before we forget, we're going to add that as well. This simplifies our function into x cubed plus x squared minus x cubed plus 2 times 1 minus 2x plus x squared. You can get rid of opposite terms. It becomes 3x squared minus 4x plus 2, which is basically another parabola. So since you have a parabola and you have lower and upper bound for your x, if you graph this, you can see at 1, you have a value. Here, this is the point that the function stops because your x is bounded between 0 and 1. At 0, you have a 2 and you have minimum at 2/3. This function is 3x squared minus 4x plus 2. If you take the derivative of this function, you can easily find the critical point, which is 6x minus 4. And when you set it equal to 0, let me rewrite this nicely. 6x minus 4 and set it equal to 0. X is 4 over 6, or 2/3. Perfect. So this function, this parabola at 0 is equal to 2. At 2/3, it's equal to 2/3. So now you can compare all of these z values from the previous page, from this page, from this slide, to make a decision about the maximum and minimum value of your function. F at 0 and 0 is equal to 0. F at 1 and 0 is equal to 1. F at 0 and 1 is equal to 2. F at 2/3 and 1/3 is equal to 2/3. So we can conclude that the global minimum of this function is at 0 and the global maximum of the function is at 2.